What I'd like to do now is go back to the pictures example. Before we were looking at them as SVG art. What we can do instead is go back to representing them as ASCII art, that is just using ASCII characters. And what we can see is it's a very nice example of how we apply some of the functions we've just met in earlier in this block. So, as I say, we're going to learn something from just looking at the pictures module. And in particular, we model pictures as lists of characters. So for example, there you see there's this horse that you render to appear like that. It's a list of characters, list of strings, and that's how the horse looks when we apply the function render to print it in the terminal. Now, we can start implementing some of those functions on pictures. And what we're doing is implementing functions over lists. So we're going to be using some of the functions we've learnt about already. Now, how do you flip something in a horizontal mirror? If you look what's happening, we have the same lines, but they are in reverse order. So flip H applied to a picture is got by reversing that picture. Or in fact, we can just, in ASCII, you can simply say the function flip H equals the function reverse. And that's what I've done there. So we get flipping in a horizontal mirror by reversing the list of lines. What about flipping in a vertical mirror? What we have to do there is we have to reverse each of the lines, but the lines remain in the same order. So how do we apply that? Well, we have to transform every element in a list, and we do that using map. So flip V of pick is map of reverse on pick. We reverse each line in the list of lines. What about implementing rotation? What we do there is we first flip in a vertical mirror, and then we flip in a horizontal one. And so we write that rotate applied to pick is flip H applied to flip V of pick. So that's saying first apply flip V, then apply flip H. And we can write that directly. Rotate is flip H composed with flip V. Let's talk about that dot operation. G dot F is apply F, then apply G. So you see it here as a flow diagram. We have values flow into F, and then they flow out from F into G, and then we get an output. And so you see that requires us to make the output of F have the same type as the input of G. And that you can see in the type that I have given to dot. The first function, the function on the left of the dot, is applied second. I know it sounds daft, but because when we apply g.f, the f gets at the argument first, and so g, the one before the dot, is the one applied second. So that has type B arrow C. And B is the input type of G, but also the output type of F. As you can see, the second type of the second argument here is A arrow B. So the second is A arrow B, the first is B arrow C, and the result is A arrow C, because that's the type of the composition. And here I've given the definition. G.F applied to X is G applied to F of X. So we've got that operator dot that operates directly on functions, and I used it in the previous example to say that rotate is flip H dot flip V. What about putting one list, one picture above the other? we simply need to join those two lists together. So above pick 1, pick 2 is pick 1 plus plus pick 2, or we can simply define the function directly to say above is equal to the operator plus plus. What about implementing beside? That's a bit more complicated because we have to join corresponding lines together, and that's what zipWith does for us. ZipWith takes corresponding lines and joins them together with plus plus. So here we have beside of pick 1 and pick 2 is zipWith applied to plus plus and pick 1 and pick 2. So we've seen that we're using map and filter and reverse and plus plus in this particular case study, and that's why I wanted to cover this, so that you can see that a lot of this ASCII art, these pixel pictures, can be described using these standard list functions.